Right chat 7 watching for okay. Chat bar. Yeah. Good evening, everyone. So let us see the solutions of the offline test we have written previously. So this is the first question, aptitude. Two numbers A and B are such that the sum of 5% of A and 4% of B is two-thirds of sum of 6% of A and 8% of B. Find the ratio of A is to B. So it is given as 5% of A. So it is 5 by 100 into A plus 6 by 100, 4 by 100. So it is 4 by 100 into B is equal to two-thirds of sum of 6 by 100 of A plus 8 by 100 of B. So you can write it like you remove all hundreds and you multiply 3 this side and 6 this side. So it is 15A plus 12B is equal to 12A plus 16B. So it is 4B is equal to 3A. So A by B ratio is 4 by 3. So your answer is 4:3. Okay. So you have, there are two candles, each of same initial length. The first candle can burn for 24 hours, while the second candle can burn for 16 hours. Both of them are lit at the same time. After some time, it is found that one of the candles was twice as long as second. Find how long had been the candle been burning. Please try this question. So let us solve this question. So it is given two candles, each of same initial length. The first candle can burn for 24 hours, while the second candle can burn for 16 hours. Both of them are lit at the same time. After some time, it is found that one of the candles was twice as long as second. This can be taken generally as distance, the distance velocity and distance time formulas. So you take first candle can burn for 24 hours. So in 1 hour, the candle, if you take length of candle equal to x centimeters. So in 1 hour, it will melt x by 24. This for first candle. For second candle, in 1 hour, it will melt for x by 16. So in 1 hour, you can take after some time the time after some certain amount of time. See, time is same for both of them. Length, they are saying it as twice of each other. So you have initial length as x minus xt by 24 is equal to 2 into x minus xt by 16, right? So in some time t, the the distance at which it is melted is x by 24 into t. For the same second candle, it melts like 2 times. The length will decrease faster, like so it is 2 into x minus x by dt. Because this is decreasing, it will be 2 times of this. So overall, if you solve this, you'll get x equal to, so it is 2x equal to again x by 16. So it is 2x 2t by 16. You can write it as x by 24, xt by 24. So it is xt by 2 to 8 minus xt by 24. So you can write into 3 by 3. You will get 2x by t. 2x by 24 is equal to x. So t equal to 12 hours. So you get time t is equal to 12 hours. Okay. So please do this question. In a competition, a school award medals in different categories: 36 medals in dance, 12 medals in dramatics, 18 medals in music. If medals went to total of 45% and only 4% got the medals in all the three categories. So how many of them has received in exactly two of these categories? So these are these type of questions generally they'll ask in gate for 1 mark. So if you see, it is given as in dance. So n of A, if you consider A as dance, you'll get n of A as 36, n of B dramatics as 12, n of music, which is C, you take it as C, you'll get 18. If these medals went to 45 persons and only 4 of them got medals in all the categories. So he's saying n of A union B union C is 45, and all 3 categories, if they get it, you get it as 4. So he's asking how many of them receive in exactly 2 of these categories. So your partition will be like this. Suppose if you take these 3, A, B, C, this is a part of intersection of this one. He is asking this parts. So you'll be having this part, and this part. So these red shaded areas are the one they are asking. So it is nothing but n of A union B minus n of A intersection B intersection C plus n of B union C minus n of A intersection B intersection C, n of plus n of A union C minus n of A intersection B intersection C. So you can take an overall equation as n of A intersection B. Oh, this is n of A intersection B, sorry. N of A intersection B, n of, this is the area which they are asking, right? These red shaded areas are the one they are asking. So it is A intersection B plus n of B intersection C plus n of A intersection C can be written as n of A union B union C we'll write it as a whole formula. Wait, 1 minute. So you have n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Right? This is the formula. He's asking n of A intersection A union B union C minus n of 3 times of n of A intersection B intersection C. So he's asking exactly this portion if you calculate. This portion if you calculate. This is nothing but total. We'll take this as x. If you take x, your x is nothing but n of A union B union C. Sorry, you can just subtract this. You can write n of A plus n of B plus n of C minus n of A union B union C. Right. Already you have the 3 intersection 3 times of n of A union B union C. Just let's calculate this one. Plus n of A intersection B intersection C. So what will you have here? So you'll have 45 plus, I mean 36 plus 12 plus 18 plus 4 minus 45. So what will you get here? Your x is 25. He is asking x minus 3 times intersection of this one. So he is asking this part, y. So you'll have y is equal to 25 minus 3 into 4. So it is 25 minus 12, you'll get 13. So your answer is 13. So your answer is, so which of the following is the which of the following could be the formula for the graph shown below? So what are these? These are nothing but your rectangular hyperbola. So for a rectangular hyperbola, xy is constant. So you can write y is equal to some constant, you can take it as k. So you can take that as k. Okay. So you have, oh, sorry. So it is k by x. So you can write your f of x as 1 by x. K can be 1 also. So this is your rectangular hyperbola. This one. So try this one. Please answer it in the chat. So if I were you, I wouldn't buy that computer. It's too much expensive, right? It's too much expensive. So please try this. Find the analogous relationship as the first pair. Coherent, consistent, then what is irate? So here, irate is a synonym for very angry. So you can mean it's not completely related to rage, very angry. So it is irritated. So coherent is consistent, irate is irritated. So please read this statement and find the relationship. So let us continue this. So we have daphthophony. So daphthophony is advisement, right? So you have emodaphta, misadvice. Oh. And you have emolopti. Emolopti as misconduct. So what is the common words if you see here? Emo and emo is common here. So common word is miss. You have dafta and you are left with kofta, right? Lofta, sorry. That is advice. So your dafta is advice. So you can eliminate this because the word asked here is statement. So if you see the statement, state, state is something which is not given here. You have meant. Meant is nothing but phony. Meant is phony. There are only two words with phony. And you see krata and lokti which is given. So lokti is the one which is called as conduct. So you can remove that. So your state is nothing but krata phony. So your answer is this one. Please try this question. You have which number replaces the question mark. So if you watch carefully here, so it is given 586 and 378 4 9 and this is x if you take it as x. So it is 8 minus 5. 8 minus 5 is 3. 3 into 2 is 6. Again 7 minus 3 is 4. 4 into 2 is 8. So again you have 9 minus 4 is 5. 5 into 2 is 10. So your answer is 10. Please try the next question. Please take some time and try this question and put your answer in the chat. So everyone has done this question? Okay. So let us see for the solution. The number of quadrilaterals which are possible for this is. So let us take. So you can consider you need 4 sides in a quadrilateral, right? 4 sides you need it. Suppose this will be your first quadrilateral. The second quadrilateral will be this one, the bottom one. Third quadrilateral you can consider this will also be a quadrilateral, right? This one will also be a quadrilateral. Or you can consider so you can consider this also as your quadrilateral. And this side also you have one more quadrilateral which is like this. Okay. So you have one more quadrilateral like this. One more quadrilateral like this. Or this quadrilateral will be like this. So still you have a quadrilateral which is at the center like this. Next, what are the other type of quadrilaterals which are possible? So if you consider this quadrilateral itself, you have one like this, one like this. So you have 2 quadrilaterals here itself like this. So one quadrilateral is like this. And one more quadrilateral is like this. This part I'm talking about 1, 2. If you'll mark actually, you'll have an idea what I'm talking about. So if I take this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So mostly what is here is I'm talking about 1, 2, 3, 4. Okay. So this is 6, 9, 10, 11. So next one, this is like 1, 4, 1, 4, 11 and 7. So you have 9, 3, 4 and 7, 4 and 8. Okay. So this one is 4, 5, 7, 8. Next. So top one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many did you get? 1, 2, 3, 4, 5, 6, 7, 8, 9. You got totally 9. Still, are there any other possibilities? Any other possibilities? Oh, this is also possible. See, this is also possible. There is one more quadrilateral like this. So you have a quadrilateral which is like this, and you have one more quadrilateral on the other side also like this. Right? So there are totally 11 quadrilaterals which are possible. Understood? Please try this question. So let us see this question. So you have an equilateral triangle. Suppose if I take this, so please share your answers in the chat so that it will be very it's a good practice for us, and you also will be checking the answers. We'll know how interested are you also. So you have a triangle like this, and you have a circle which is covering like this. Okay. So in this circle, he is asking this area to be known, this area. So what I'll do is, this is the center of the circle, because this is a circle, this is an orthocenter, semicircle he told already. So this is the orthocenter. So from here to here, if you draw a triangle, so this is nothing but a sector in a circle. So I know the area of this triangle. This triangle will be what? If you consider this as equilateral triangle, this is an equilateral triangle only. This is 1/4 of radius of equilateral triangle, because in an equilateral triangle, this will be divided into four parts: 1, 2, 3, 4, right? So this is 1/4 of the area of the equilateral triangle. So what is it? Root 3 by 4 into 1 by 4 into your side is nothing but 14 square. So it is what is the side? So it is root 3 by 4 into 7 square, right? So it is 49 root 3 by 4 is the area of the triangle. You need, what is the area of the sector? Sector is nothing but pi by, you need to find the angle, right? What is the angle here? 60 degrees equilateral triangle. So what will be the angle? So it is pi by 6 into side of the triangle, side square. I mean pi r square. I mean theta by half. What is the area of the sector? Theta L square, right? Pi r square for the triangle you take. So it will be what? So your half theta L square. So it is nothing but half of 60 degrees. So your theta 60 is equal to pi by 3. So it is half of theta L square. L is what? Your side of a triangle. So it is 7 square. So your triangle is 49 pi by 6. So what will be the area? Your overall area is 2 times of the area which is given. See, this area and this area is 2 times. So it is 2 times of 49 pi by 6 minus 49 pi by 6 into 49 root by 4. So you can write 49 pi by 3 minus 49 root 3 by 2. So your answer is B, right? Please do this. So you need to understand here. You need to understand whenever you need to find rank of a matrix, row AB is given as whenever you want to find the row of a matrix. Suppose if you have rank of a matrix, row of A is something, rank of a matrix, row of B is something. You need to understand that it can be equal to any of them if both are equal, or it can be less than also. So maximum value will be minimum of row A and row B. So it can be less than to this. So it is less than or equal to the minimum of row A and row B. Please do the next question. It's a very good question. You'll get these type of question as MSQs in GATE. So do this question. We'll discuss this in 10 seconds. So you have f of x equal to 1 by 1 minus x. So he is asking f of continuity. Where are the points of discontinuities you need to find? Fn is nothing but f like this you continue till n times. So you have f of x is nothing but 1 by 1 by 1 minus x, which is 1 by 1 minus 1 minus x is nothing but minus x by 1 minus x. So it is again x minus 1 by x. So you need to understand two things. So again, if I write f of x, what am I getting? I'll get 1 by 1 minus x minus 1 by 1 by 1 minus x. So what do you get here? Minus of minus, you get x by 1 minus x by 1 by 1 minus x. So you get x here. Again, after fourth time, right? So if I write f to the power of x, I'll get x in this place, I'll write 1 by 1 minus 1. So for every fourth value, again, there is a repetition. So periodic is like, first one you get the same thing, again you'll get x minus 1 by x, again you get x, after that again you get 1 minus x. So you get a periodic function which is repeating after third time. So you need to understand with these all functions will give you discontinuity points. So in first one, if you see, what is the point of discontinuity? Your discontinuity is x equal to 1. And in second one, if you take x can be 1, but x cannot be equal to 0. So x cannot be equal to 0, x cannot be equal to 1. Here x can be anything. Again, your discontinuity will start with x equal to 1. So what are your points of discontinuities? It is x equal to 1 and x equal to 0. Okay. Nowhere you get x plus 1 in the denominator. So this is not the value. The function is not continuous everywhere. You have 2 points of discontinuities. Okay. Please do the next question. So you have five numbers which are given as 5, 10, 15, 5, 15 again. Now, what would be the sum of deviations? So, what is the mean value? We'll check it. Mean value, if you take it, because he's asking deviation from the mean. What is the mean value? You have 5 plus 10 plus. So, it is x, e of x you can take as 5 plus 10 plus 15 plus 5 plus 15 by 5. So it is nothing but 1 plus 2 plus 3 plus 1 plus 3. So what is your mean value? It is 6 plus 4, 10. So you see individual deviations. You have individual deviations if I ask. So it is minus 5, 0, plus 5, minus 5, plus 5. So it is plus 5, minus 5. Sum of deviations is nothing but plus 5, minus 5 cancel, plus 5, minus 5 cancel, 0. So you get answer as 0. Please do this question. So let us see how to solve this. We have uh, third d by dx cube is nothing but you can write this as minus of dy by dx whole power 4 plus y square whole power 1 by 3. So your degree and order is nothing but highest degree whatever you see and to the power you can write it as order. So you have d cube y by dx cube whole cube. So it is minus of you can leave like that because minus of cube root is again minus only. So you can leave it like this. So your highest degree is this one and the order for this is 3. So it is 3 and 3. The inverse Laplace transform of s by s plus 5 by s square plus 4s plus 4 is. Please try this Laplace transformations. So we'll solve this question. So it is Laplace of, see first directly solving the Laplace, see whether you can convert this into simpler fractions or not. You can write this as s by 5 by s plus 2 whole square. So you can write this as s plus 2 plus 3 by s plus 2 whole square by s plus 2 whole square. So you get 1 by s plus 2. So you get 1 by s plus 2 plus 3 by s plus 2 whole square. You need Laplace inverse for this. So you get L inverse of 1 by s plus 2 can be written as e power minus 2t. L inverse of 3 by s plus 2 whole square can be written as what? See, when there is a constant on the top, you will get it as 3t into, it is again s plus 2 whole square. So it is again 1 minus e minus 2t. So sum of these two is nothing but e minus 2t will be taken as common. You will get 1 plus 3t. So it is A. Someone is already giving the answers. Please do the next question. Please try to participate in the chat. Please solve the questions and give answers. So we'll do questions continuously from this. From now we'll be little quicker. So you have eigenvalues. For finding out eigenvalues, you will find characteristic value, which is a minus lambda I. So this is nothing but, so you have 5 minus lambda 6 17 0 minus 19 minus lambda 23 0 0 37 minus lambda equal to 0. No one has answered this yet. This is just solving this quadratic equation. You have 0 0. So you can flip this up. You can also write this as 5 minus lambda 0 0 6 17, and this can be written as minus 17 minus lambda. 23 can be written here. So you can write 0, 37 minus lambda. So overall, you'll be getting 5 minus lambda into these two options, minus 17 minus lambda into 37 minus lambda equal to 0. So overall, your values are 5 minus 19, 37. So 5 minus 19, 37. So answer is A. So only three people are answering it. Please try to answer it in the chat box. Please try the next question. So here you have eutectic. For eutectic, what is it? For eutectic, you have liquid giving you solid plus solid. For monotectic, you have what is monotectic? You have liquid giving you one liquid plus solid. For peritectic, okay, I can write this as eutectic. For peritectic, you'll be having liquid plus solid giving you liquid solid, and syntactic is remaining. Syntactic is liquid plus liquid giving you solid. So what is the answer? You get eutectic P2, and uh, monotectic is Q is 1. Liquid giving you liquid plus solid. Yeah, Q is 1. So it is 2143. So someone is given the correct answers. So please solve this question. Yeah, very good. Please solve the question. So this question, if you see, so in a binary alloy consists of 2 moles of copper. So in a binary alloy, you have 2 moles of copper. Copper is 2 moles. And then you have, so very good. Someone is already giving the answer. So we'll try it. So copper is 2 moles, nickel is 3 moles. The weight percentage of copper. How do you get weight percentage? You need to find out weight of copper to total weight of this. So 2 moles is what? 2 into 63.5. 3 moles is what? 3 into 58.7. So if you find out what is the weight percentage, it is nothing but 2 into 63.5 by 2 into 63.5 plus 3 into 58.7. So let us calculate this in the calculator. You get into 100 also you can do it. So you can do this into 100. So it is 2 into 63.5 is 127 by 127 plus 3 into 60, nearly 180 you can take. So it is 127 plus 180 again, you will get nearly 303 into 100. 120 plus 180. So you get 41.9%. So your answer is 42. Very good. Range will be there. So you have a range of nearly +1. In the exam, you try to take as much as possible nearer to your answer. You can write 42 or 41 as answer. So in eutectite steel, which one of the following does not form on continuous cooling? So if you have a continuous cooling, which one does not form? You doesn't get, someone has already answered it. It is benite. See here. So this is your see, one thing I want to make it clear here. So suppose you have this as your TTT curve. This is start, this is finish. But in continuous cooling, you'll be only having this part. Because see, why does it happen? In an isothermal cooling, your cooling will be very slow. You can cool like this, you can cool like this, like this. But in continuous cooling, your cooling will be very faster. It will be like this, very faster, right? So there is no chance for it to form fully Bennett. See here, suppose if you take the curve like this, if I put anywhere, the curve doesn't go like this. Continuous cooling is like very fast drop will be there. Okay, isothermal cooling only you'll have this much difference in temperature, time versus temperature. So you have very large amount of time only in isothermal cooling. In continuous cooling, your time is very less. So you can come to here, but there won't be any Bennetic finish. So you won't be having fully Bennett structure. Which one of the following is an austenitic stabilizer? Please write this. So remember, you have austenitic stabilizers. What are austenitic stabilizers and ferritic stabilizers? So you have chromium, molybdenum, vanadium, beryllium, silicon, aluminum. These all are manganese, nickel, nitrogen, carbon, copper, zinc. These all are austenitic stabilizer. So you have manganese here. So it is A. Right. Many of them has done it correct. Good. So resistivity of a pure copper. So resistivity of a pure silicon, sorry, at room temperature is 3000 ohms. Mu E is equal to 0.14, mu H is equal to 0.05. The intrinsic carrier density is dash into 10 power 6. Please try this. So you have the pure resistivity of pure silicon at room temperature is 3000 ohm. Mu is equal to 0.14, mu H is equal to 0.05. The intrinsic carrier is. So you can calculate your sigma is equal to n into mu E plus mu H into charge. So you have n is what? Oh, he is asking the same thing. So it is 3000 equal to n is the one you need to calculate. So 0.14 plus 0.05 into 1.6 into 10 power minus 19. So you get n is equal to 3000 by 1.6 into 0.19 into 10 power 19 minus 19. You can write it as 19. Oh, did I do anything mistake? Oh, resistivity is given as this. So it is 1 by 3000. So it is 1 by 3000. So what is the value? You get n is equal to 1.095 into 10 power 16. So someone has already given the answer. So for a perfectly diamagnetic material, you will have magnetization, you can take magnetic susceptibility as x equal to, this has -1. So it is not 0. This is not the answer. So you have m is equal to -h, x equal to -1, and you can take b is 0. There is no magnetic induction for a perfectly diamagnetic material. Okay. Please do this question, 23rd. So your wavelength should not be greater than 3.46. So please, a bar of 10 centimeter long is elongated, drawing to 20 centimeters. Which one of the following options are not correct? Engineering strain is E and true strain is epsilon. Please do this. So you have E is equal to elongated by this is delta L by L is 10 by, so it is 10 by 10, you get E is equal to 1. So epsilon is ln 2, 0.693. So your epsilon is 0.693. So epsilon is greater than E. What are the options which you have? Sorry, less than E. What are the options you have? Epsilon is greater than E. Epsilon equal to E. E is equal to 0.693. So these three are wrong. So your answer is ACD, not AD. Okay, it is ACD. Next, for which of the following Schmidt factor is M is equal to 0? So Schmidt factor for which your this is 0. So your M is nothing but cos theta into cos phi. Your angle should be either, it should not, if you consider it should not be equal to 90 degrees. Any of the angle should not be equal to 90 degrees, either theta or phi. So in what cases do you have this? So this is A, this is B, this is C, this is D. Please write accordingly. Please answer in the chat. So you have, so your answer is here, your one of the angle is 90 degree, 80 degree, 90 degrees, right? So if it is 90, M is 0. For option B also you see loading direction and this. So your this angle is not 90 degrees. So normal is like this. So you have a different angle in option B. In option C, again, the slip direction and normal is again perpendicular. Loading direction, though it is in the parallel direction, cos 0 is not 0, but this is again perpendicular to it. So again, loading direction, this both are perpendicular to each other. So again, this is 0. So in these three cases, it will be 0. So answer is A, C, D. Which of the following is structure sensitive property? So structure sensitive property is the one which changes along with the how you change the structure, the property changes. So example, density is the one which is structure insensitive. Structure is like total mass by total volume, right? So density, temperature, pressure, these are structure insensitive properties. Structure sensitive, if you take yield strength, creep strength, fatigue strength, electrical conductivity, these all are structure sensitive. So your answer is A, C, D. Again, it is A, C, D. Okay. So please try this. Vacancies are thermodynamically necessary defects. The presence of vacancy increases the configuration entropy of the material. So if you see Ellingham diagram, here the graph is between delta G and T, right? So your delta G, if you write delta G naught equal to delta G naught and T, delta G naught equal to delta H naught minus T delta S naught. So these are straight lines, right? Straight lines. So how do you get these values are nothing but your delta H naught values and your x axis is T. So your slope is minus delta S. So your answer is B. Please do this question. So you have a sample undergoes first order reaction. After 30 seconds, its concentration decreases to 20 degrees. The initial concentration decreases to 20% of the initial concentration. So for a first order reaction, dC by dt is equal to, you can write it as minus Kc because the concentration is decreasing. So you can write dC by C equal to minus K dt, integrate both sides. You get ln C is equal to minus Kt. So what is it with respect to this? You can put values from C naught to C. It will be C by C naught equal to minus KT. So you can see that this is dt, temperature time difference. After 30 seconds he told. So it is minus K into, after 30 seconds it is 30 ln. This concentration decreases to 20% of initial concentration. This is ln 0.2. So what is ln 0.2? Ln 0.2 is, so your K is equal to minus 1.609 by minus 30, which is 0.045, 0.0458. So you get 0.046. You can approximate up to 3 decimals. Please do this question. So you have two metals. Two metals are welded together. After few years of exposure to seawater, B underwent a heavy corrosion. So when B underwent a heavy corrosion, case 1 and case 2 you see. Corrosion will occur as shown in case 2. Corrosion will occur in case 1. Corrosion, both the cases will be equally probable. See, equal probable is very less, right? Equal probable, oh, so when you take equal probability, only when there is a surface contact, there you can see there is a more possibility of corrosion which is being happened than to the, okay, the surface, here also it can get corroded. But this is the area where there is more electrode potential difference between these two, right? So here the corrosion will start. So he is given corrosion will occur in case 1. So answer is this one. Less probability that it will occur at this area, right? So it is B. So your conductivity will be higher for metals. So in these metals, aluminum has more conductivity than iron. Then next comes your liquid water, then your saturated water vapor. See, whenever you take air or vapor, this will have very less conductivity, right? So your answer is SPQR. Please do this question. So let us see this question. Which of the following is an example of forced convection? So for a forced convection, chilling effect on cold winds on a warm body is not, right? So then you can go for cooling of billets in atmosphere is not. Generally, if you take industries, for cooling these billets, they'll use very big stand fans, right? Like this. They'll cool like this is forced convection, but cooling billets in atmosphere is not. Heat exchange on cold and warm pipes is not. So your answer is B. Please try this. So considering two edge dislocations, when they come together, you have opposite signs have slipped. They are separated by several atomic distances and indicated by the diagram. What defect will result? See, these two are dislocations where you have vacancy here and here. When they come together, these vacancies won't disappear. These vacancies will stay like this. If they are of opposite signs, I mean, they are of same sign, like this, like this. So then, suppose if it is like this and like this, on the same plane, these two dislocations will combine together and will, what you can say is, annihilation of dislocations will happen. So this will give you a vacancy. V will be your answer. Please try this question. So for the same diffusion of depth, for the same depth of diffusion, so sorry, it is given at diffusion time. Depth of diffusion is given as at 500 degrees centigrade, and at depth of diffusion at 500 and 800, 850 degrees centigrade is in the ratio of 1:6. So you have, x by 2 root dt is equal to constant. So your x1 by x2 whole square equal to d1 by d2. So it is exponential minus q by r into 1 by t1 minus 1 by t2. So it is x1 by x2, it is 1 by 6 square. So it is ln 1 by 36 equal to minus q by 8.314 into 1 by 773 minus 1 by 1123. So what is your q? Let us calculate. It is 74 kilojoule per mole. What measures may be taken to increase the fatigue resistance of metal alloy? So polishing removes the stress amplification sites, reducing the number of internal defect by means of altering process and fabrication pores. Modify the design to eliminate notches and sudden contour changes. Soften the outer surface. So you have polishing, relieving internal stresses and amplification, reducing number of internal defects by means of altering the process and fabrication techniques. So decarburization is the one which increases your outer surface. So that will increase fatigue resistance. Okay. Decarburization is making your this one softer. So you need a harder surface, right? So carburation is the one. Modify the design by eliminating notches. Reduce the number of internal defect by means of altering process and fabrication techniques. This might not completely affect it, but it helps in decreasing your fatigue. It helps in decreasing your fatigue failures. So your answer is A, B, C. Okay. So next one. For the special case, you have sigma z equal to 0 and again tau yz and tau zx is 0. The relationship is given as for Ex, you can write Ex equal to 1 by E into sigma x minus nu sigma y. Ey is equal to 1 by E into sigma y minus nu sigma x. So you can write sigma x minus nu sigma y equal to E into Ex. Sigma y minus nu sigma x equal to E into Ey. So you multiply this with nu, you will get sigma y into 1 minus nu square is equal to E into 1 plus no no. You can write nu into Ex plus Ey. So you get sigma y is equal to E into Ey plus nu Ex by 1 minus nu square. Or you can write sigma y is sigma x, you can write Ex plus nu into sigma y. So your answer is D. To the next question. Limit x tends to x power n. You can write 1, you will get overall 1 plus 1 plus 1, so or 1 n minus n by 1 minus 1. You get 0 by 0 form, you can apply L'Hospital rule. So if you apply L'Hospital rule, you apply derivations to the numerator and derivation to the denominator. So you get n into x power n minus 1 plus n minus 1 into x power n minus 2 plus so on minus 0 by 1. So you get, if you put 1 here, n plus n minus 1 plus n minus 2 plus so on till 1. So you get n into n plus 1 by 2. That is nothing but 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus so on till n by 2. Their answer is A. A piece of copper has a measured density of 8.91. The lattice parameter of FCC copper is 3.6153 and its atomic mass is 63.51. The volume percentage of vacancies in pure copper. So you have, it's given as a piece of copper, a measured density of, the density is given as, so percentage of vacancy is what? Volume of final minus volume initial by volume initial into 100. So for the same mass, you can write it as density of initial minus, because volume is inversely proportional to density. You can write density of initial by density of final by density of final into 100. Right? So you get, what is this final, what is this initial? This is nothing but density theoretical minus density actual by density actual into 100. So what do you get here? The volume percentage of vacancies. So theoretical is equal to Zm by Na into Aq, which we can calculate normally. What is that? FCC. FCC has number of atoms 4. So 4 into mass is what? 63.51 by 51 by Na is Avogadro number into, you can write, if you write your density as, okay, what do you want here? You are calculating theoretical density. If you want it in gram per cc, you can write this in cubic centimeter cube itself. So you can write 3.61 into 10 power minus 10 centimeters. So it is cube, right? So what do you get? So you get, what is given actually here? What value are you getting here? It is according to the calculation. So let us put in the value. So it is 8.93. So your percentage of vacancy is nothing but 8.93 minus 8.91 by 8.91 into 100. So it comes to 0.22 percentage. Your answer is 0.22. Please do the next question. So let us do this. You have 1 kg of 1 kg of diatomic oxygen is present in 500 liters tank. Find the specific volume on both masses and mole basis. So it is given specific volume. Specific volume on mass equal to 0.5 by 1, which is 0.5 meter cube per kg. You have specific volume on mole basis. So you have 0.5 by 1 by 0.032. Okay. This we have writing in grams actually, because this is given in kg. So it is 32 grams. You are converting into kg. You get 0.016 meter cube per mole. So you get 0.5 and 0.126 meter cube per mole. Next one. So you have PQRS. Never a herring is for vacancy diffusion along crystal structure. Vacancy diffusion along grain boundary. You have for this grain boundary sliding is 2. Then this one is 1. So your answer is D. For a zero order reaction, A giving you B, the initial concentration of A is 10 molar. If half-life of the reaction T 0.5 is 2 minutes, then concentration of B after 3 minutes is. So for a zero order reaction, you have dC by dt is equal to KT directly. No, K directly. So you have K, C minus C naught. Change in concentration is nothing but KT. Initial concentration is 10. Half-life is this. Half-life is half-life is 2 minutes. So for this, you have half-life as this one. You have A naught by 2 for it to become half. You have minus KT 0.5 plus A naught. So overall A naught by 2 is nothing but you will have KT 0.5. Already it is given as 2 minutes. You need to find concentration after 3 minutes. So let us find the value of K. K is equal to concentration is 5. 5 by 2 it is 2.5 molarity per minute. So you have K value. It is asking what is the concentration of A after some time. So it is nothing but A minus 10 is equal to 2.5 into 3. So A concentration will be 2.5 is what? 7.5 per minute, right? 7.5. So this is change in like leftover concentration, C minus C naught. Your leftover concentration is 7.5 molar per minute. So your answer is 7.5. Again, I'm telling you, he is asking the concentration of B. See, zeroth order A giving you B, the initial concentration of A is 10 molar, half-life is C, the concentration of B after. So whatever this is left, so A is left only 2.5 molar. Whatever which is changed will become B. Determine if the series converges or diverges. You have 6 plus 8n plus 8n square. See, whenever you have these kind of problems, you divide everything with 1 by n square because highest denominator, highest power in the numerator is 2. Highest power in the denominator is also 2. So divide everything with 2. 6 by n square plus 8 by n plus 9 by 3 by n square plus 2 by n plus 1. So if these values you get as 0, then you can say it as convergent. So what do you get this value? When you put n is equal to infinite. So when limit n tends to infinite, if you do this test, this is called as divergence test. You get, what is the value you get? 0 plus 0 plus 9 by 0 plus 0 plus 1. You get 9 which is not equal to 0. For 0, convergence. For this not equal to 0, divergence. So it is divergent. So you have a copper based alloy contains the following elements in the composition. If the maximum possibility corresponds to E by A is equal to 1.38, which of the following is correct? So you have, you need E by A. E is nothing but number of electrons. A is nothing but number of atoms. So let us see for maximum solubility corresponds to E by A. So maximum for your alloy is E by A is 1.38. What you need to find? You need to find, okay, a copper base contains this. For this composition, what is it you are getting? So let us calculate number of electrons. Let us calculate number of atoms. So for copper zinc alloy, so what is the composition? What is the electrons which you get? First, let us consider it. The whole is for 100 grams. So now copper will be 74 by 63.5. Zinc will be 20 by 65.3. Aluminum will be 3 by 27. Silicon will be 3 by 28. You got moles from this. Moles is what? If I calculate, I am getting 1.165. Next one is 0.612. 3 by 27, 1 by 9, you get 0.428. No, 0.333. Oh, this is 1 by 9. This is 1 by 9. Wait, 1 minute. So I'll get moles into its valency also. So you get into 1, into 2, into 3, into 4. This is how you will be getting moles because see, valency is nothing but electrons. You are calculating E by A values only, no? So E by A moles you are calculating. So you have 0.612 moles of electrons. So you have 0.33, no, sorry, 1.165 moles of electrons. You have 0.612 moles of electrons. You have 0.333 moles of electrons and 0.428 moles of electrons. So what is the total moles of electrons? Total moles of electrons is 1.165, 0.612, 0.333, 0.428. You get 2.538 moles of electrons. Okay. What is the total moles of atoms? If you ask me for atoms, it is nothing but 74 by 63.5. 20 by 63.5. This is nothing but number of moles. 1 mole contains 6 into 10 power 23 atoms, right? The same way you get 3 by 27, 3 by 28. This is the moles of atoms. So what do you get moles of atoms? Moles of atoms is equal to 74 by 63.5 plus 20 by 65.3 plus 3 by 27 plus 3 by 28. So overall number of moles of atoms you get is 1.689 moles of atoms. So what is E by A value here? E by A is 2.538 by 1.689. So you get nearly as 1.5. You get answer as 1.5. Whenever you have this maximum solubility corresponds to 1.38. But what is the actual solubility? So I got 1.5 as the answer. So your answer is actually the alloy which you got is actually having more E by A than 1.38. So it would not have a single solid solution. If your value is less than this only, it will get completely dissolved and be as a single solid solution. If it is greater than this, it would not have a single solid solution. So your answer is A and C. I think everyone understood this. Next one. For some transformation having kinetics that obeys our Avrami equation, the parameter n is known to have a value of 1.5. If after 125 seconds, the reaction is 25% complete, how long will it take for the transformation to go to 90% reaction? So you have F is equal to 1 minus exponential minus kT power n. So you have, so we want to find time. So it is already given 125 for initial value of how much? 25% completion. So it is 1 minus 0.5. So it is 1.75 equal to ln of 1 by 0.75 is t power n. You can say t1 power n. N is nothing but 1.5. For ln 90% completion, you are left with 0.1 is equal to t2 power 1 by 5. So you have ln of 0. Ln of 0.75 by 0.1 is equal to ln of t1 by t2. So it is into 1.5. Ln t1 by t2, 125 by t2. So what do you get here? T2? T2? So if I put this in the calculator, ln of ln 0.5 by 1.5, exponential of this 2 by 125, I am getting, so your answer is 500 seconds. So it takes 500 seconds. Chemical potential is defined as, see for dou H, you can write dou H as in terms of entropy and pressure, right? Dou U is equal to TdS minus PdV. This you can write as U plus PV. H is equal to U plus PV. So you can write it as TDS plus VDP. So you can write in terms of entropy and pressure. This is correct. So DG you can write as H minus TS. So it is nothing but VDP minus SDT. So it is with T and P. This is also correct. U you can write as in terms of entropy and pressure. This is also right. A you can write as in terms of T and V. So this is also correct. So chemical potential, all are correct. Now, for the below normal distribution, which one of the following options hold true? Sigma 1, sigma 2, sigma 3. Standard deviation are 1, 2, 3. See, if you see correctly, standard deviations from here, this value says this has a very small standard deviation. Your sigma 1 is the least one you have, because that is the sharper one. Means when it is very narrow, you mean deviation is very small. So sigma 1 is less than, sigma 2 is less than sigma 3. So delta G mixing, binary system consists of A and B. Delta GA is a partial molar free energy of A. Dou delta G mixing by dou XP. This you can write it as, delta G mixing. How can you write? XGA bar plus XA GA bar plus XB GB bar. So this if you differentiate delta G mixing, you have dxa GA bar plus dxp GB bar. You can write with respect to xb if you want to do. If you want to differentiate with respect to xb, xa you can write as 1 minus xb. So if you put it here, you will get dou delta G mixing by dou xp is equal to, this you can write as GA bar minus dxp plus GB bar dxp. So you can write this as, sorry, for this I can write like this. So it is d delta G mixing with respect to dou xp is equal to, or I can write dxp is equal to GA bar minus GB bar. Oh, GB bar minus GA bar. So it is GB bar, or you can write it as delta GB bar also. So it is delta GB bar minus GA bar. So it is D. The solution parameter, this depends on what? See here, tau you can write it as EAB, some factor K into EAB minus half of EAA plus EBB. This decides you. If this bond energy is more, overall value will be positive. Means this energy is higher. So always AB wants to dissociate into AA and BB. If this value is less, your delta G is negative. Then whenever this is negative, your regular solution parameter is negative, always AB is stable. So it will form a solid solution or a miscibility gap. So it depends on coordination number, it depends on bond energy. This is the bond energy. It depends on total number of atoms in the solution, but not mole fraction of the component in the solution. Okay. So it is proportional to energies and number of atoms, but not mole fraction of the components in the solution. You will write Gxs as this into Xa Xb. So your this part depends on Xa and Xb, not solution parameter, right? So to face alpha and beta in a thermodynamic equilibrium, if X and Y are two components, they are asking about equilibrium. So thermodynamic equilibrium you will have when mu A alpha equal to mu A beta. So you have a graph like this. If I extend like this, if I have one more, I'll have two solutions like this. So one is like this and one is like this. So these two, if I join, I get this is A, this is B, you can take. So UA in alpha is equal to UA in beta. UB in alpha equal to mu B in beta. This happens only when then you can say these two are in equilibrium. So can you see that if x and y are components, you can say mu a x alpha, mu x beta. So this is not, this is not, your answer is C. So answer is C. So your 2C plus H2 will give you C2H2. Given C2H2 plus 5O2 is equal to 2CO2 plus H2O. Your delta H1 is minus 1299.5. C plus O2 is CO2. H2 gas plus half O2 gas equal to H2O liquid. You have delta H3 is equal to minus 285.5. So let us do this. So 2CO2, you have this energy. You want to calculate enthalpy of this delta H. So how do you get delta H of this? This delta H is nothing but this delta H. How did you get this equation? This delta H is nothing but you have it on product side, right? So this will be delta H minus delta H1 because this C2H2 should be on the opposite side. So this is minus delta H1 plus you need two carbons, right? So it is plus 2 into delta H2 and you need carbon on left side itself. And then you have plus delta H3. So what is the answer? You get 1299.5 minus 787 minus 285.8. You get plus 226.7 kilojoules. So your answer is plus 226.7. A circular plate with 1 meter in diameter and 1 meter in thickness is submerged vertically in water. Such its upper edge is 8 meters below the surface of water. So now the total hydrostatic pressure force on the side of the plate, if you see. So you have a circular plate of 1 meter dia and thick is submerged vertically. So you can see vertically in water, so that upper edges. Oh, you're submerging it like this. So this is 8 meters and this is 1 meter. Free surface. The hydrostatic pressure, if you see, P, if you take P is equal to rho GH, then P is equal to F by A. Next pressure, P is equal to F by A. What do you want? You want hydrodynamic pressure force. So you want F here. So F by cross sectional area. Where is the pressure acting exactly? The pressure is acting on the area which is surface area 10 power 3 into 9.81 into. Oh, this pressure. How do you get rho GH 10 power 3 into G is what? G is 9.81 into what is H here? H is nothing but 8 plus 1 by 2. So you get 8.5. So you get F is equal to pi by 4 into diameter of this is 1 square into the pressure which is given. So overall, what do you get the value? You get 65.4 kilonewtons. So your answer is B. The value of convective heat transfer depends on the convective heat transfer depends on so the convective heat transfer depends on property of the fluid's viscosity, density, specific heat, nature of the fluid, geometry of the fluid, but not conductivity of the material. Conductivity of the material is K. H does not depends on K again. Heat flows through a composite slab as shown in the figure. The depth of the slab is 1 meter. So if it is 1 meter, so heat flows through a composite slab as shown in the below. The depth of the slab is 1 meter. The K values are in watt per meter. Okay. So you have the overall thermal resistance is Kelvin per watt. So we'll see you have this conductivity plus this resistance plus this resistance between C and A, and this is B. I can take this as A part, B part, and C part outside. So what are the thermal resistance? We'll calculate. This is R1, this is R2, this is R3. So R1 equal to L by Ka. R is nothing but L by Ka here. It is 0.5 by 0.02 into 1 into 1. It is 25. So for R2 it is again L by Ka. It is 0.25 by 0.01 into 0.5 into 1. So it is 5 kilowatts. R3 is equal to L by Ka again. You get 0.25. This width is 0.25. Then you have K is equal to 0.04 into 0.5. You have 12.5. So overall, your effective resistance is nothing but you have this has 25 plus 5 into 12.5 by 17.5. So it is again, you will get nearly 29. So your resistance is 29. Which of the following minerals is subjected to magnetic separation method? See, rutile is iron ore, chromite is chromium, ferrous, cobalt, nickel, chromium, all are magnetic material. Siderite is again a ore of iron, which is carbonate ore of iron. So again, it is also magnetic separation. Galena is zinc sulfate. This is not magnetic. Okay. Next, scaffolding, chilling of earth, channeling, hanging. Let us see this. So if you have scaffolding, scaffolding is nothing but you have something will stick to the surface of the walls. Okay. So let us see any option which is there. Action of volatile metals. Yes, this is due to action of volatile metals. Oh, you have only one option which is related to it. So let us see for the other options. So chilling of earth is nothing but the leaking of Bosch and earth cooling plate, sudden lowering of fixed carbon content of the coke. So chilling is related to 1. So your answer is 2143. Channeling is due to non-uniform blast distribution. So drop in the blast pressure. Hanging is increasing flame temperature due to the hot blast temperature decrease. Okay. PQRS, again we'll see. You have flotation. Flotation is related to flotation is due to you can see difference in hydrophobicity. That and heavy media separation is difference in specific gravity. So first one is 2, third one is 1. So your answer is this one. Jigging is due to linear acceleration 4 and tabling is due to difference in lateral movements. So your answer is 2413. B. LD converter is charged with 10 tons of hot metal containing 3.5% carbon, 1.25% silicon, 0.75 manganese, and rest iron. The impurities are oxidized and removed from the hot metal by lancing pure oxygen and 40% of carbon oxidized to CO2, 60% of carbon to form CO. Determine the total amount of oxygen required. Given 1% of iron is lost to the hot metal, atomic weight iron is 55, silicon is given. Okay. So let us see this. What do you want? Total amount of oxygen. So if we calculate whatever amounts which requires oxygen, like 1% is going to is lost, right? So this will also get oxidized. So you can take weight of carbon plus weight of silicon plus weight of manganese plus weight of iron. Whatever this is lost, this will get oxidized. See, generally when hot metal, if it is lost, it won't be converted from FeO to Fe. This is the only point you need to remember. Otherwise, you can check from the options also. So C will be converted. See, what is the weight of carbon? You have 3.5 by 100 into 10,000, 1 ton, right? Or 10 tons, right? So you have 350 kg of carbon which is required. This will get converted into CO and CO2. So 40% of C is converted to CO2. So it is 350 into 0.4, 140 kg is converted into CO2. Then this 60%, remaining 60% is converted into CO. So you C50 into 0.6 equal to 1 to 210 kg. Now this is not solved yet. You need volume of oxygen. So total amount of oxygen if you want, C for CO2 to get converted, you need 1 mole of O2. So you can write it as, for this you can write it as 140 by 12 into 22.4 will give you 261.3 normal meter cube. So for this you can say 210 by 12 into 22.4 will give you 196 normal meter cube. Okay. In the same way, if you convert silicon to this, so silicon percentage is what? Silicon weight percentage is, so this is silicon. Silicon weight percentage is 1.25 by 100 into 10,000. You get 125 kg, right? 125 by 28. So this 125 kg by 28 into 22.4. This is the volume. So we'll write separately. This is the weight. I'll write it like a table. So this is weight. This is volume. So what is your weight for this silicon? You have manganese next. Manganese is again 0.75 by 100 into 10,000. So you get 0.75 by, what is the manganese weight? You need to convert this into oxide, right? Manganese oxide, if you take, manganese is almost having weight of 55. So you can write 55 into 11.2. Oh, this is 100 by 10,000, you get 75. So this is the volume of manganese. You have iron, which is 1%, 1 by 100 into 10,000. So you have 100 by 56 into 22.4. Oh, okay, this is also 11.2 because for Fe, you convert into FeO. For Mn, you convert into MnO. For Si, you convert into SiO2. That is why it is 22.4 liters. That means 1 mole of oxygen, half mole of oxygen, half mole of oxygen. So overall, what is the volume? So what is the volume you have? Overall volume is 261.5 plus 196 plus this, if you will calculate, I'll get this total volume as, I get overall 592.6 normal meter cube. So it is 592.6. So in commercial production, which of the following metals, metallothermic reduction is not used? So the one which has very low metallothermic reductions. So metallothermic reductions is the one which is reducing by metal itself. So generally, if you take all the precious metals, generally they won't be getting reduced by metallothermic reduction. They'll undergo electro refining methods like copper, zinc, nickel. These all will undergo metallothermic reductions. Will not undergo metallothermic reduction. Zirconium can undergo. Which of the following will be there? So which are the following? See, if you draw the roastates of sulfur, roasters of sulfur, if you have roasting of sulfides, you have this one. This is PS2, PSO2, and this is PO2. So you'll have This is your pure metal. This will get converted into oxygen. At higher temperature, both metal sulfates will occur, right? So if you take these both can occur together, you will have metal sulfide at high pressures here. Okay. So you can take P sulfur, partial pressure of sulfur, you can take. Then partial pressure of sulfur and O2. So at higher temperatures, you will have this kind of pressure. And this is metal sulfide, and this you can take MXSY, this type. So equilibrium will be there between what and what. So MO/MS, yes, there is an equilibrium between MO/MS and SO4, right? So this is there. There is equilibrium between metal and metal sulfide. Metal sulfide and metal. Okay, you have equilibrium between metal sulfide and metal and oxygen. So this is also there. Metal and metal sulfur is nowhere. Metal sulfide is nowhere. So this is wrong. So overall AB is the right answer. In sand casting process, a sphere and a cylinder of equal volumes are separately cast from sand, molten metal under identical condition. The height and diameter of the cylindrical are equal. So you take height and diameter of the cylinder. So height of cylinder equal to diameter of cylinder. So what do you need here? The ratio of solidification of sphere. Okay. What is given? A sphere and a cylinder of equal volumes. So you have 4 pi by 3. No, this is sphere, right? Sphere, you have, you can take RS. For cylinder, you can take RC. So you have 4 pi by 3 R. You can take capital R and small r if you want. Small r. This is nothing but pi R square H. So here your R and H, what do you have relation? Is asking diameter equal rate of solidification of. Okay. So you can write H is equal to R by 2. No, 2R. So here you can write 4 pi by 3 r cube, pi gets cancelled. You have 4 r cube by 3 is equal to small r cube into 2, because this is nothing but 2r. So again 2 gets cancelled. So 2 r cube equal to 3 small r cube. So this is the relation. He is asking the relation between time for solid, time for sphere and time for cylinder. You have volume of sphere by area of sphere by volume of cylinder by area of cylinder whole power 2. So you have volume of sphere by area of sphere, volume of cylinder by area of cylinder. If you write, you will get ds by 6 into 6 by dc. So square. So you get ds by dc. Already we got relation here. So you can write dc is equal to, so r is equal to 1.14 small r. So these you can write sphere. This is sphere. This is cylinder. This is nothing but 1.14 square. So 1.14 square is 1.31. Your answer is this one. See, when you stop here, this option is also there in this. This is how they give great questions. So here you can write as D is equal to 1.14 into D is cylinder. So electrodes used in spot welding are made up of, they are generally made up of copper, tungsten, but not generally with, and also with aluminum. So spot welding are required to produce a high amount of electrical conductivity. Hence, copper and aluminum, copper and chromium. Oh, sorry, copper and chromium, not tungsten. Spot welding is like you need to immediately weld it, and they need to have higher conductivity. So answer is A, B, C. Submerged arc welding is not recommended for high carbon steel, tool steels, aluminum, magnesium. This is true. Submerged arc welding you won't be using for high carbon steel, tool steels. This is because the unavailability of suitable fluxes, reactivity, high temperature, and low sublimation temperatures. Need not be. See here, it doesn't depend on unavailability of suitable fluxes, reactivity, high temperature, and low sublimation temperature. Submerged arc welding, generally it is not recommended because of the. So how do you do this? There, suitable fluxes will not affect it much. You will be using suitable fluxes only. So there you will be seeing, you'll already be covering it completely. Then you'll insert this electrode deep into it. After it is welded completely, this surface itself will, the oxide layer will itself will act as a shield. Now low sublimation temperatures. No, low sublimation temperatures are not there. Generally, they will be melted inside, deeper inside. That is why they have higher temperature itself. So A is false, B is true. The bite angle where rolling plates is 12 mm thick using work rolls of 600 diameters, reducing thickness by 3 mm. So you have, suppose if I take delta H square, delta H is equal to mu square R. So your delta H thickness is reduced by 3. Your mu square and R is nothing but 300 mm. So your mu is equal to 1 by 100 root. So it is 0.1. You have mu is equal to tan alpha. So you can write alpha is equal to tan inverse mu. So you can write tan inverse of 0.1. For very small angles, you can say alpha is this one. But for tan inverse 0.1, let us see the value of tan inverse 0.1. What will it be? What will it be? So tan inverse of, you get 5.71. Your alpha angle is 5.71 degrees. So your bite angle will be 5.73. Brass billet is to be extruded from an initial diameter of 100 diameter. Then a brass billet is to be extruded to an initial diameter of 100 to final diameter of 50 mm. The working temperature is 700. The extrusion constant is, so you have extrusion force. Extrusion force P is equal to Ka ln Ai by Af. This is nothing but Kai. So extrusion constant is already given 250 into 10 power 6 Newton per meter square. You have Ai initial temperature is pi by 4 into 0.1 square into ln Ai by this is nothing but 1.96 by 7.854. So what do you get this value? Let us calculate this. So you will have the overall value to be, so you will have 2.72 million Newton or mega Newton. So wrinkling is a defect, PQRS. PQRS if you take. Wrinkling is a defect which is for what? So wrinkling is because of insufficient blank die forcing. Then earring is a defect which is because of what? Excessive, no, sorry. Oh, let us see. Orange peel effect is due to large grain size. Wrinkling is due to your excessive blank die forces. So it is 4312. So you can take Sprinkling is due to insufficient blank forcing. Orange peel is due to large grain size. Cheshire strain, it is for yield point elongation. Earring is due to anisotropy. So it is 4312. So that's all for today. So we'll stop here. Thank you.